And so a lot gets lost in this term Industry 4.0 because people say it, hey, you cannot buy an Industry 4.0. There's no off-the-shelf Industry 4.0 widget that I can buy. And you're right. That's just marketing, maybe. But in reality, the genesis of Industry 4.0 is not from marketing. It's from an initiative that was created from the German government. What happened is they recognized that after World War II, they rebuilt. And as they rebuilt, they had the latest technology available to them. But obviously, it's been 50, 60 years since those plants have been built. And they're aging. They're what we call brownfield plants. However, across the globe, new plants are being developed, particularly in the BRIC countries, Brazil, Russia, India, China. Those countries are getting new plants with the new technology. These technologies. Those plants are getting these technologies. And what the German government realized, it says, in order for us to maintain ourselves as manufacturing leaders in the world, we have to invest in these technologies. So we've got to incentivize our manufacturers to do this. And they called these set of technologies as Industry 4.0. So it's not just marketing. It's a necessity. We are in the same situation in the U.S. as Germany is. Our plants were built, a lot of them built before World War II. So it's incumbent upon us to also continue to invest in these technologies. Now, to show that these technologies are really real, I want to give an example of a water organization who we piloted a program with is machine learning analytics. Remember, I talked about how we want to learn what is normal so that we can identify abnormal. And so we did a pilot where we monitored the booster pump stations so that we could collect all the data that they have in the historian, pump that into Insight, and allow Insight to monitor that 24/7. The reason being is in times of stress, maybe droughts, right? You've got to have these systems functioning. But if you look at this is a real trend. This is the real data, real trend. If you see this, I don't know if you could tell whether there's a problem there or not. I know I couldn't. The operator couldn't. And what's the guarantee that the operator is looking at this data? Well, there wasn't. I'm telling you, there wasn't. And no one would ever have found that there is an anomaly starting right here. So you can see, this is an anomaly score. It went here, up to here, and it says, I find something that is completely out of the normal. But looking at it, you're like, I don't know, is that normal? I mean, I can't tell. So if you drill in, well, first, this is what it looks like when it sees an anomaly. It shows you, hey, these are the things that we noticed that were wrong. And when you monitor a pump, in many cases, you monitor the temperature of the pump so you can detect things like bearings going bad. So it's creating more friction, it's getting hotter. But what if the actual thing that's measuring for failure fails? And that's what happened here. So this is actually alerting on the temperature, the RTDs that were in those pumps. And you can see this is normal operation. Now that I've zoomed out a little bit, this is what normal operation looked like. But here, once we got the alert, you can see that that is completely not normal. But you wouldn't have been able to see that from a normal trend. You wouldn't have been able to, you most likely wouldn't have been looking at the temperature variations You were always just looking at some threshold of temperature, right? In fact, all your alerts. But these are still within the threshold, but it's odd. And so what they ended up doing is sending somebody out to take a look at these, and that's what they found. Bad RTDs. They ended up replacing the RTDs, and that resolved the entire problem. So the moral of the story is, we didn't anticipate finding a problem with the thing that measures and looks for problems, but we found it. Well, we didn't find it. Insight found it. And you never know what you're going to find when you actually start monitoring these things. And you start just looking for normal and not normal. And that is a much easier thing to do than some of these other analytics packages. So what happens is many people have got this concept of big data, and big data is going to solve everything. But the problem with big data is it takes big resources, a lot amount of data scientists. It takes R and Python programming. It takes Azure cloud services that with some customized skills in order to make use of the big data. And you have to make sure the data is actually correct when it gets there. It has to be clean. In fact, when you actually are doing big data, 90% of the work is actually cleaning the data. The other 10% is actually building the models. And then if you have time lags between your data, well, how do you reconcile all that? And that's a big job. But what if you actually started with this concept of smart data, where you picked things and you did something smaller in the sense that, hey, we know we are going to monitor this asset, and we're going to monitor these 20 things, and we're going to look for normal, not normal. That is a faster time to success than the big data concept. So big data is good. Big data is fine. You should still go for that. But you got to have these layers of analytics in order to actually get value